Hello, NG India. Hey, my name is Prateek Bhatnagar, and I am working as a front-end engineer at Coinbase. Uh, Working at Coinbase has been pretty recent. Before Coinbase, I had a 4-year spell at Google, and I worked with a bunch of teams as AMP team, as Aurora team, which Michael just also pointed out. And I'm super glad that I'm following Michael's talk because a lot of what we are going to explain is like at least half covered by Michael. So thank you, Michael. You put me in a great spot here. Okay, before we get going, I would just like to thank NG India organizing committee to basically organize this amazing event, get the community together and get Angular stronger in India presence at least. So yeah, thank you so much. Now, to start with, we are going to talk about Web Vitals and Core Web Vitals. And before we begin, like, I just want to highlight one thing. Like, is this another just a big prescription by the big the big browser or the search engine company? We have had other prescriptions like Rails performance model. We have had other prescriptions like you should be doing SSR so that your search engine optimization works better and the crawlers know them better. However, luckily, the Web Vitals is basically not really just a prescription. It's backed by a bunch of feedback from open source projects. It's also backed by a deep user research by Google team. So, and these metrics that we are going to talk about are basically categorized into three main buckets. One is paint timings. So we'll talk about different kind of paint metrics. The other one is responsiveness of your application, like how responsive is your application. The long tasks, the janks that Michael just showed are basically some of the most biggest bottlenecks when it comes to responsiveness of your page. So we'll talk about first input delay, we'll also talk about interaction to next paint metric, and then the last bucket is stability, like how stable is your page. If a user is trying to do something, is your page just jumping around? Is the content moving around too much to make it frustrating for the user, or is it stable enough? So, a little bit of background of where exactly, like why do we have Web Vitals? Why do we have Core Web Vitals? Anyone here who has worked on the AMP project, built AMP pages, or remember AMP? The open source project by Google? No one? A show of hands? Okay, some of you. All right, not as many as I would expect, but sure. So the AMP project was is basically an open source project by a small team in Google. What they do is it's a component library based on web components. If you build with this, toolbox, if you build with this component library, they guarantee you a very good performance of your web pages. However, there's a catch here. It's entirely based on web components, and a bunch of companies, a bunch of developers had a problem that, hey, we are already maintaining a tech stack with Angular, we are already maintaining a tech stack with, say, React and a bunch of other things. And if we were to maintain our AMP pages, like it's a totally different tech stack and we have to maintain duplicate pages for ourselves. So as a part of it, the AMP team started contributing to bigger open web projects as well. And their contributions, like there are numerous contributions from the AMP team. They can be categorized into three buckets again. Like one is web standards. So things like native lazy loading in web today is one of the biggest contributions that AMP team made. Then there are fetch priorities that we just discussed, and then importance of a particular asset of loading order is something that AMP team also contributed to. The second set is metrics. I'll skip this over and come back to it. The third one is a reusable UI component. AMP team has also built a Bento.js library which is way more reusable into other tech stacks like Angular or React or other frameworks. It's not just a web component library that has to be built and supported with web components solely. It's a much more easy to reuse library, and you can basically just use it in your Preact applications or React applications. Now back to metrics. While AMP pages were supposed to be faster, there were an internal set of metrics which the AMP team used to measure how fast a certain page built by a developer is in comparison to other ones. Using these metrics, certain AMP pages were shown in the top carousel of Google search and the others were not. These metrics basically came forward into open web community and are now called Web Vitals. This is an ongoing effort. You might see more Web Vitals in near future. Right now there are five Web Vitals. First is the first contentful paint, then there is the largest contentful paint, then there is first input delay, interaction to next paint, and cumulative layout shifts. We'll talk about all of these. What these metrics does is it will tell you from a real user point of view, is your page behaving fast enough or not? Is your page stable enough or not in real world? These are not lab metrics. The collection of these metrics happen when real users visit your websites and are stored from there. A small difference is what are core Web Vitals. Out of these 5 metrics, which we will discuss in detail, 3 metrics, which is largest contentful paint, first input delay, and cumulative layout shifts are also measured by Google to rank your pages now. So if these 3 metrics are not good, are not looking good for your pages, your search engine ranking might go down. That's the base difference between Web Vitals and core Web Vitals. Core Web Vitals are direct signal to search engine rankings, versus Web Vitals are a broader set which you can use to measure your page's performance. A good thing about these 5 metrics is how we measure this. Like, all of the Web Vitals are measured through similar methodology, which is you gather your real user metrics, all 5 of them. You get your P75 of these metrics. You don't average them, you don't take out a median, it's the P75th which is measured, and you put them into one of the 3 buckets. Every metric has all these buckets, which is a good bucket, or it needs an improvement, or basically it's a poor execution bucket. All of these metrics have different boundaries to these buckets, and that's basically how you can measure it. Remember, like when you are getting your real user data, take P75th of them, and that's basically what you should be measuring while measuring Web Vitals or core Web Vitals. Okay, now to get started. First one is first contentful paint. This basically measures when is the first thing gets painted on the DOM. Basically, imagine you are writing a URL, you press and enter. The time between you requesting that page to the first thing getting painted on the DOM, that's called first contentful paint. It's perceived as, by a real user, it's perceived as the thing that, yes, the URL that I've requested is alive and is responding. So you really want to be as fast as possible to tell your user that, yes, we are responding, the application is not down, something is soon to appear. Basically, any images on the page, any SVG elements on the page, all these, any block elements on the page, all count towards contributing to FCP. As we said, the 3 buckets for FCP is like, if your page needs to be considered as performing good, FCP needs to happen below 1.8 seconds. Like, it cannot be more than 1.8 seconds, and it will be put in the green bucket. The needs improvement bucket is somewhere between 1.8 to 3 seconds, and if it's more than 3 seconds for your P75 of your traffic, then that's basically where you really need to start looking into it. So what does first contentful paint look like? Here's the preview. Okay, skip too many slides. Yes, so I profiled the NG India website itself, and what I found, like, this is on 3G, and I'm using web page test for measuring all these Web Vitals. what we see is up till 4.5 seconds, there was nothing on the screen, and the first paint appeared to be on 4.5 seconds. This is not objectively good or bad, because you have to gather your real user traffic and then get this metric. But right now we are using 4G for this, and it takes about 4.5 seconds for the first thing to appear. Similarly, in a server-side rendered app, this is what it would look like. Something gets started to paint at 4.5 seconds, and while other things get loaded up till 7 seconds. So we mark your first contentful paint at somewhere around 4.5 seconds. There are few things that are known to be notoriously problematic for first contentful paint, and some of them are slow time to first byte. If you are processing too much on your server, you are probably too late to respond to your user as well. So slow time to first byte is one of the biggest contributors in poor first contentful paints. The second one is a client-side rendered app. So imagine if you were to download all your CSS, all your JavaScript, then execute all of that JavaScript and then the data, and only then you can paint a page. That's a lot of work before showing something to the user. If your page is server-side rendered, it basically has a bunch of DOM, or all you need to do is download some style sheets and apply and start painting it on the DOM that you already have. So if your application is client-side rendered app, you need to be really careful where your FCP lies, because there's a lot needs to be done before you can actually show any pixel on the page to your user. And the last thing is synchronous scripts in the head. Some of the biggest problems on the web occurs from synchronous scripts, and that too when they're high up in the head. If you are trying to use a third-party script, going for ads, going for analytics, always make sure your scripts in your head are not synchronous. What happens with synchronous scripts is browser sees the synchronous script tag, which is basically a script tag without defer or async attribute, and it stops everything until it's downloaded and parsed and is executed. So even if your app is server-side rendered, if you have everything ready to go and you put a synchronous script tag in head, your browser will halt itself from painting, from layout and anything else, and will just try to first download and execute that script. And therefore, like, synchronous script is an absolute killer for first contentful paint. Building on first contentful paint, next comes is largest contentful paint. Like, first contentful paint can be literally anything. It can be a top bar, it can be a logo, it can be something as meaningless as just a hamburger icon which does not do anything, right? Largest contentful paint tries to measure the largest image or the largest block element on the page, which is perceivably more meaningful to your users. It can be a hero image, it can be the biggest heading of your page, and this is basically where your web page starts making more sense to your users. So things like image elements inside SVG, or a hero video on your image, which is a banner video on your web page with a poster inside it. So only the poster image is considered, not actually the playing video. And an element with a background URL, or basically if none of these are present, then the biggest block level element, which is the biggest div, biggest section, and so on. Whatever are the block level elements that are on your page. For LCP, obviously, the good bucket is a bit more relaxed, which is 2.5 seconds. The needs improvement bucket is from 2.5 to 4 seconds, and then anything further apart is considered as poor. Here's what LCP and FCP looks like in a client rendered app. You download everything, you execute everything, and bam, all of it is ready at an instant. At the same time, here your first contentful paint and your largest contentful paint are at the same time. If you are using something like web page test, it also tries to highlight the purple box, which basically tells you which is the element which is being marked as the largest contentful paint. This element could be a hero image, this element could be a poster of a video, or this element could be, in this case, a largest block level element. Whatever comes first would be whatever comes as the biggest element would be marked as LCP element. Let's take another look. Let's take a look at another example. This is a server-side rendered app. So you see, at around 5 seconds, it found an LCP candidate with a heading on the top. However, going up to 10ish second, it found a bigger element, which was the hero image, and thus that frame at 10 seconds was considered to be the LCP for this page, and the element with the image is considered to be the LCP element. That's how the server-side rendered apps and how client-side rendered apps would differ. The server-side rendered app would definitely have a bit of a window where you can distinguish your FCP and an LCP. Right. So coming towards like what are the common pitfalls of largest contentful paint? Whatever is problematic for your FCP will obviously always be problematic for your LCP as well. If you can't paint the first pixel, you obviously cannot paint the most meaningful pixel on your page. Apart from that, if you have a hero image and it's lagging in priority, that would cause severely poor performance of LCP. If you have a hero image, imagine, and you are trying to lazy load all your images, that would mean your page is the layout is done, your page is painted, and now some JavaScript is trying to find which images are in the viewport. Then the download has started, and it will basically appear after all of these steps. So any kind of lagging priority of your hero images would cause poor LCP. Third is again synchronous script due to all the reasons that I just explained. Fourth is if there are no scripts, imagine, and all you have is a text, right? And you're using a custom font with display block. This basically means the font has to be downloaded and nothing will be shown, just a white screen, white placeholder would be shown until the font is downloaded and applied to your text. So if in case the font is not your branding, then always try to go with a display swap or display optional so that the font itself could be shown as soon as possible. Versus with display block, it's just blocked and nothing is shown on the screen, and hence you will get a poor LCP again. And interestingly, fifth thing is something that when we were trying to analyze a bunch of web pages, what we found as the biggest culprit is a premature optimization. A lot of developers read a bunch of articles and start lazy loading their images. Don't do this for your hero images. Please always ensure that your hero images should be highest priority and should be loaded at the very beginning. If possible, always use the browser's native image lazy loading, because it can do this much faster and much better than your JavaScript code can. Okay, those were the paint metrics as we discussed. The next two are response metrics. The first, FCP and LCP, tells how fast your page is painted. The next two, first input delay and interaction to next paint, will tell how responsive your page is to your users' requirements. So FID, or first input delay, is basically a measurement. If the page is now painted and I'm trying to interact with something, after how long of a time do I actually get a feedback? The buckets here is every time my first interaction to my first response, the time difference should be less than 100 milliseconds. The needs improvement bucket is 100 to 300 seconds, 100 to 300 milliseconds, and anything beyond that is poor performance. Much like what Michael just showed, one of the biggest contributors or one of the biggest problems in this is your boot up time. This metric has a special quality that this is not lab testable. Like you can create a bunch of scripts and try to interact with your page, but they would hardly cover 1% of what your real users would do with your page. So with tools like web page test, with tools like Lighthouse, you're not shown this metric. This metric is only capturable through your real user data. However, as you see, like in the very beginning, there are a bunch of long tasks, and this is basically where your page is painted and your user is trying to interact with your page, trying to press a button, trying to write something, but your JavaScript is running and executing in one micro task and is not letting your user actually do what they're trying to do. So if you are building an Angular app, please follow all the things, all the amazing things that Michael just demoed. If you are building other things, I'm sure there would be other techniques that you can use. However, the trickiest part here is the Webpack bootstrap time, and one of the most common answers there is load as less code as possible and lazy load the other code. So the Webpack has this tendency of loading all the required modules from the network and then initializing all of it at once. That's where some of the poorest FIDs track into, and so please try to break your code, lazy load your code as much as possible. As we discussed, like some of the most common pitfalls for first input delay is a very long running task in the beginning towards the beginning of your app, or too many modules being initialized during the boot up of your app. The most common answers when you are trying to debug an FID is ship less code in your first code. Okay. Next is cumulative layout shift. So if you are trying to do something with a page, but the page keeps jumping, content keeps loading, content keeps shifting, that's basically what is called as a layout shift on the page. However, you are totally okay to respond to user interactions and then shift the content on the page, but you only have a 500 milliseconds of a window after it. If your content is shifting without any user interaction, that's basically what is measured as CLS. Your page's cumulative layout shift score should always be less than 0.1 second. 0.1, the score is given between 0 to 1. 1 is where the content is shifted towards 100% of your viewport height, more than 100% of your viewport height. If it's only 10%, then it's basically 0.1. Here's an example of what cumulative layout shift can look like. If something is loaded, which is basically the left hand side of the screen, and another thing comes in and shifts it down, this is without any user interaction, without any intervention of user or any action of the user, this is now being recorded as cumulative layout shift. Another interstitial came in and basically shifted the content below. Some of the common things that people do that causes cumulative layout shifts are unsized images. You have a hero image, you have a big chunk of sections underneath it, and the image just loads and fill in whatever the available space is. Causes huge CLS issues. Please make sure that you are taking care of it. Another very interesting thing that we found is custom fonts but with variable heights. So imagine if you're using a custom font, but the fallback font and the custom font have difference in height. Excuse me. So whenever the custom font will load, it will start shifting the content below and will also cause a significant CLS. Third is unregulated ads. Like again, just like images, if your ad just loads after some time and shifts your content below, that's a very poor experience for your users and should be basically given intrinsic height and width values. The fourth one is what we saw in the example, lazy loaded interstitials or lazy loaded banners. Your page is ready, I'm trying to interact with the page, but suddenly a banner or interstitial comes in and acquires the actual space, and I accidentally click on something else which other than what I was actually trying to click. Causes another set of problems for cumulative layout shift. The last one is the most recent one, is a bit experimental one. It's called interaction to next paint. If I interact with something on your page, I should get a feedback to it. However, like the difference between clicking a button or doing something on the page versus the actual next paint of the page, that difference in time is called interaction to next paint. This time we need to keep below 200 ms. If it's from 200 to 500 ms, then still it's considered as needs improvement. Anything above that would be considered as poor. Here's an example of it. So I'm trying to click the image and nothing is happening. Like, versus if you see on the right hand side, let me see if I can play that again. On the right hand side, what you'll see this is as soon as the person clicks the color, we quickly paint the next frame. We quickly show a progress bar that we are loading something, and then we basically update the paint, the actual image. This is what interaction to next paint is. On the left hand side, the user is basically stuck and don't know if something is happening in the background, if I have clicked or not, if I need to click, if I need to tap harder. Versus on the right hand side, there's instant feedback. Some of the things that cause higher interaction to next paint times are longer tasks after clicking a button or any particular action by the user. If your application takes way too long time to process your JavaScript or to get that data, that would result in a higher interaction to next paint. Or if it basically just goes in a frenzy and is non-responsive for a very long time, then again it causes a higher score of interaction to next paint. These were the five These were the 5 metrics which are called Web Vitals, and out of which 3 are measured in your search ranking for your pages, which are core Web Vitals. Next up, we'll see like what can be basically used to measure core Web Vitals. One of the first thing is, and the easiest thing out there, is web page test. The new refined UI of web page test, it basically just lets you choose a drop down, choose core Web Vitals, put in your URL there, and it basically tests your page on 3G. You can basically just expand the advanced section and choose a different kind of network if you want. Next option that you have on your hand, and this is actual real user data, is using your Google Data Studio. There's a link in here on this on the slide which will basically just get you to the right template. You need to put your URL out there, and what Google has crawled for you passed over like 1 month will be given to you as scores. And the last, if you are like a web developer and if you want something in-house, that would be Web Vitals JS itself. So you use this library using Performance Monitor. You basically just capture all these Web Vitals, and you're free to send it to your own database. You're free to send it to your analytics service or wherever you like. This JavaScript library only helps you collect these metrics. What you do with those scores is totally up to you. Okay, that's basically the entire description of how core Web Vitals are measured and seen by a bunch of web developers and their libraries. If you have any questions, I'll be around. Thank you.
Thank you. Thank you, Prateek. Thank you so much. That was an excellent session on core Web Vitals. Thank you so much again.